All right, mathletes, we are going to go over section 6.3, and we're going to look at some of the properties that trig functions have. We've seen how to evaluate them in a couple different ways, so let's talk about some of the properties. So here's a couple of the basic ones. So the first one says sine of theta plus 2 pi equals sine of theta. So if you added 2 pi to theta, you would get the same exact answer. Same for cosecant, cosine, and secant. And for tangent and cotangent, you can do that if you just added pi to it. So what on earth do those really, do those really mean? Well, it just means that the function values repeat. So you don't get, completely new trig functions. They start to kind of cycle over each other. All right, moving on. The other basic property is sine of negative theta equals negative sine of theta. Same for cosecant and for tangent. But for cosine of negative theta equals a positive cosine. And same for secant. So we've seen functions like these before. Do you remember what those were? Yes, we do, Professor Jordan. That means that they are odd and even functions. And then I'd say, yes, you were totally right. But then I would have a follow-up question. How do you know which one is which? And then you guys would all tell me, well, when the negative goes away, that's when it's an even, and when the negative's kind of like been pulled out, or you have the opposite, that's when it's odd. Nicely done, class. Thank you. All right. Example 1, find the exact value of these three things here. Well, if you notice, 19 pi over 4, that's way over 2 pi. So what they're doing is they're just rotating around more than once, which is totally fine. But we kind of want a better angle to work with. So an easy way to adjust this is to just keep subtracting 2 pi until you get an angle that's 2 pi or smaller. And it's positive. So if you subtract it once, that'd be 11 pi over 4. If you subtract it again, that would be 3 pi over 4. So that's the angle that we're really trying to evaluate, sine of 3 pi over 4. So whether you use the unit circle or SOHCAHTOA or whatever you do, it would come out as root 2 over 2. All right, part B, same thing, just keep subtracting 2 pi. So you could subtract it 3 times and get it down to cosine of pi, which is just -1. Now, part C, you have a couple of options here. One of them is the angle is negative, so what you could do is you could add 2 pi and you can keep doing that until it gets to be positive. Or you can use the odd and even functions. So like for cosine, because it's got a negative in there, for cosine it doesn't matter whether the angle is positive or negative, they are equal to each other. So you could go like that and then just do what we did before, just keep subtracting 2 pi until you get it to an angle that you like. So no matter which way you went, you can even do that here with that negative 5 pi over 3. No matter which way you go, and it doesn't matter if you use SOHCAHTOA or you the unit circle, you are going to get 1/2 as your answer. Okay, find the exact value of secant of negative pi over 18 times cosine of 37 pi over 18. So in that first one, I'm just going to use the odd even property. So the negative just disappears. For the 37 pi over 18, I'm going to do that over on this side. I'm going to subtract 2 pi to give me pi over 18. So I have secant of pi over 18 times cosine of pi over 18. And that's going to equal 1 because they are basically just reciprocals of each other. Okay, so trig functions, they have nifty little things that allow us to change and manipulate them into other expressions. These identities are extremely useful when solving problems, evaluating expressions, and proving other identities. And they're so much fun. And I'm not being sarcastic when I say that. I actually do think these are kind of fun. Says the math teacher again. So let's go over some of the basic ones. So the quotient identities. Number 1 is tangent of theta. That is sine over cosine, which should kind of make sense because we said it on the unit circle, it was y over the x. Well, the y is sine and x is cosine. So cotangent, if you follow that same logic, that would be cosine over sine. So those are the only two quotient identities we have. But we do have several of the reciprocals. And we've talked about them already. But let's just go ahead and write them down. So like tangent, that's the reciprocal of cotangent. So then it stands to reason that cotangent is the reciprocal of tangent. Cosecant is the reciprocal of sine. So that means sine is a reciprocal of cosecant. Which you don't usually use that often, but it's there. And then secant is the reciprocal of cosine. All right, let's go ahead and fill out the Pythagorean identities, and then we'll stop and make a new video for the actual use of them. So the Pythagorean identities, these are really powerful. So if you don't remember these from your trig class, you're going to want to know them for this class because they are going to come back into calculus and in other places in here. So the Pythagorean identities resemble the Pythagorean theorem. So number 1, sine squared of theta plus cosine squared theta equals 1. Number 2, tangent squared plus 1 is equal to secant squared. And number 3, cotangent squared plus 1 equals cosecant squared. Okay, so let's stop here and pick it up in the next video.